Hello everyone, this is the video for lab 7 on image analysis. In this lab, we're going to classify particular images and detect the changes on land cover of particular satellite images from Landsat 8. So the data will be provided, the imagery, but you can also learn how to download the satellite images, the Landsat images from USGS Earth Explorer from other videos. You can also check these links. So the data has been provided for September 19 and October 14 for 2017 of a mountain of Colorado. So we will try to detect the changes on the vegetation and also do some image classification using the supervised method. So there are several deliverables. Okay, if you drag one of them, this is the image of September, and this one is for the October. And the changes are also visually present here. You can see like the vegetation cover has reduced in the month of October. So one deliverable is to create the false color images and provide the maps of the false color images of this both timeline. For that you have to change the red, green and blue bands. So these are the bands of the satellite images present here. So currently it is on the true color symbology, but you have to convert it to false color. For that you have to convert the red into near infrared, then the green one to the red band and the blue one to the green band. So it will convert it to false color, and this false color actually helps us to identify particular features or particular land covers, like the very dark blue parts here are the water bodies, and the reddish color is representing the vegetation. The more the color is reddish, the healthier the vegetation is. And simply the true color is the color that we see with our eyes. So this is the deliverable one, where you have to make changes to the bands of RGB and provide the map with a map layout with the two maps showing the false color of these two satellite images, one from September, one from October. And you can see that yes, the reddish color is representing the vegetation, which is quite higher in amount in the month of September and lower in the month of October. So you have to produce two panel map of this false color images. And to note the differences in images you see and why it is seen, like the simply the changes in seasons bring changes in the vegetation cover as well. So in September there were more vegetations, and in October the season just changed and there is less vegetation cover. Okay, so NDVI, or Normalized Difference Vegetation Index, is another index that helps us to compute and estimate the vegetation health of particular satellite images. The value ranges from 1 to -1. The higher value and closer to 1 represents healthy vegetation, and the lower the value of NDVI, it represents lower vegetation health or no vegetation at all. Okay, we will use a particular tool So the tool is not here actually, so you have to go to imagery for that, and you will find out the NDVI from here. Like if you go to the indices, you'll find out NDVI. We will click on this standard one because there are others, other NDVIs, but if you just click on it, remember to click on your satellite image that you want to calculate the NDVI for, and just click on the NDVI and it will calculate the NDVI for you. So I have already calculated the NDVI for September. Now I will be calculating the NDVI for October. So I'm done doing this. The white color is representing the high healthier vegetation, and the black colors are representing the lower vegetation. However, it is showing the maximum and minimum amount of these images, so don't get confused. Like even if you are seeing high white shades in October, but it's representing lower vegetation, it's representing the vegetations with lower percentages, or not healthier vegetations. So more healthier vegetations with the value 1 are present in September, but no healthier vegetations, a very little amount of healthier vegetation is present in October. So don't get confused. These are just showing some ranges, and due to the color scheme, the stretch one, you can see some differences among these. Like don't get confused, as there are so many white shades in the October one. Still, the white shades are showing less vegetation because this has lower NDVI value. However, now we are going to perform a raster calculation to classify healthier vegetation in both of these satellite images, and we are taking the threshold of 0.35. So we are gonna perform our analysis with the healthier vegetation available in September and October images. So by doing this, you will find out that what portion of the image of October has healthier vegetations, and we took the threshold of 0.35. So it will simply get us those pixels that has the value over, and that has the NDVI value of over 0.35. You can just save it anywhere. And by doing this, for both of these satellite images, you will find out that which pixels or which areas has healthier vegetations in the images. And you can see that there is a binary classifications of 0 and 1. 0 is showing that these are not the healthier vegetations, and the healthier vegetations are the red pixels only. So we can see that there is a very less amount of healthier vegetation present in October. You can see that these are very scattered and very light in amount. Now we will do the same for the vegetations of September. And if you do the same, it will show you the healthier vegetations with the value higher than 0.35 for the satellite image of September. Okay, you can see that there are so many, a very large amount of area covered by healthier vegetations in the time September. So the change is visually very present. So this is one of your variables where you will provide the difference of vegetation cover within a month. For that, you have to subtract the one of the vegetation cover raster from the other. Like I'm subtracting September, October vegetation from September. You can do any of these. Actually, both of these will work, and maybe the value is different, but it doesn't matter. You can subtract any one of these from the other. The value of that particular class might be different, but this is the gray. The gray color is here is showing the changes in vegetation cover within this month. And if you do the opposite, you will find out similar results, but with a different class value. If you run it, this shows you this, the red color. The red class here is showing the change. So for the deliverable, you have to keep only the change. Yes, you have to keep the red color only, and this will be one of your maps that is showing the change of vegetation within a month. So image analysis is very helpful to find out land use and land cover changes. Okay, at the very end of this lab, we will do a supervised classification to find out particular land use and land covers, and this will be another one of your deliverables. Okay, there is a land color classification, image classification schema from NLCD 2011, and we will only classify these 5 classes that are indicated in the PDFs. So I'm selecting the September one, and you can change it to RGB again so that you can see the true color and make your classification and take some samples easily. You can take the default classification schema from here, set your output location, and if you continue and the next, you have to take some samples from your image to perform your supervised classification, and the classification has already been created here because you have chosen the default classification of NLCD 2011. So you can see that I'm selecting some sample polygons for water, then some sample polygons for the developed area, the built-up areas. So I think these are the built-up area. It will show you a preview. You can just uncheck it and take your samples again. So the more samples you will take, the more accurate your classification will be. However, the task is quite very tough. Like, it's very hard to get the accurate image because there will be some similarities and contrasts in images, even though the image is just from a single land cover. Like here you will see shadows of the mountains, and these shadows will make you confused. Like, you have taken black color for the vegetation and you are taking black colors for the shadows, or taking black color for the waters as well, because it actually performs the classifications based on the values of the pixels, the colors. So it is very tough to get the accurate pixels out of this classifications. So to try to take as much as samples you can, and also try to take the samples that are quite very similar in color. However, it's gonna be very difficult to get the perfect image. You can just take a look at those preview so that you can delete your samples and take samples again and see that whether your image is correct or not. As I have taken very randomly and a very less amount of sample, you can see that my classifications didn't went very well, and it doesn't look well, because you can see so many places has water, and the forests are also not seen correctly, and the other things as well. So it's your deliverable, one of your deliverable as well, to note any inaccuracy you see, and why do you think that yes, there is inaccuracy occurring. So check this PDF file and provide your deliverables correctly.